Okay, so when we're multiplying monomials, I understand a lot of you like to distribute. And that's definitely for that basic one, I totally get it. But once you get to complex ones, where we get to multiplying binomial and trinomials, I'm going to focus more on dimensions, okay? So I'm going to teach you a little bit about dimensions. And once you understand dimensions, it's going to be easier to understand how I approach this. Again, for the first lesson, you might not think, or you might not find the value in dimensions, but I want you to just trust me, okay? So if I was to give you this, all I'm asking you to do right now is to find the dimension. So the dimension of this would be a 1 by 2, because there's 1 on the outside, and there's 2 on the inside, 1 by 2. If I had this, this would be a 1 by 3, because this is 1, it's all touching. And then there are 3 groups here. 1, 2, 3, or 3 terms if you want to be fancy. That's the dimension of that, a 1 by 3. If I had this, the dimension of this is a 2 by 2, because in the first group there are 1, 2, and in the second group there is also 1, 2. So that's the dimension of that, would be a 2 by 2. If I had this, the dimension of that would be a 3 by 2. If you look at the first parentheses, 1, 2, 3. The second parenthesis, 1, 2. Okay. Now that we understand basic dimensions, I'm going to show you how I would approach this problem. Okay. So the first thing I'm going to do, and again, if you want to do your little distributive property, I totally understand. But I'm going to be consistent, because by the time I get through a problem like this, the same way I do this problem is the same way I do this problem. And kind of going like this and like this and like this, it's just so out of control. Okay? So the first thing I'm going to do is I'm going to state the dimension. It's a 1 by 2. And that is something I'm going to want you to do on the test. No matter what method you use, you need to state the dimension. There's 1 here, and there's 1, 2 here. Now what you're going to do is you're going to draw a box that has a dimension of 1 side by 2 sides. I know that can be a little bit confusing, so let me go back to this. If I was doing a 1 by 2, so let me show you an example of how I would draw the boxes for these. Let me move this back a little bit. Since the dimension of this is a 1 by 2, I'd go 1 high and 2 across. The dimension of that would be a 1 by 2. Here's 1, there's 2. This would be a 1 by 3. 1, 1, 2, 3. 1 by 1, 2, 3. Seems a little bit confusing, but trust me, you'll get to it. The dimension of this would be a 2 by 2. So 2 down and 2 across, which if you see it makes a box. 2 by 2. Then the next one, this is a 3 by 2. So you're going to go down 1, 2, 3, and across 1, 2. So it's 3 high, 1, 2, 3, and 2 across. Okay? So now let's go back to this one. So based on the dimensions, what I'm going to do is the number on the outside will go here, a 2. And then each group will have its own box. And now what your job to do is to multiply to figure out what goes in the box. So 2 times 7 is 14, and there's an R. And notice how I cover up this one. That way I'm really focused there. And then I cover up this, and now I'm going to go 2 times -4, which is -8. So my answer is 14R minus 8. Let's try another one. Let's come down here. The dimension for this one is a 1 by 2, so I'm going to write that down no matter if I do this method or if I do, I'm calling it the box method. Okay, so I'm going to go 1 high, 2 across. I go like this. The 1 goes on the outside, and the 4n takes it to the first box, and the positive 6 takes the second box. What am I going to do? I'm going to multiply. So I'm going to cover up this so I focus on the box. 8 times 4 is 32. But then when you're adding little numbers, when you're multiplying exponents, you add them. So if I have 1n and 1n, I really have 2n. So that's 32n squared. Now I'm going to cover this up. And I'm going 8 times 6 is 48, and I just have an n, and it's a positive. So now my answer is 32n squared plus 48n. Okay. Let's jump down to number 9. Number 9 has the dimension of a 1 by 2. 1 high, 2 across. Doesn't matter whether you make the box small or big or medium, whatever. Make it work for you. Negative 3m, 1m plus 5. Multiply. Multiply the bigs. Add the littles. Negative 3 times 1 is negative 3. If I have 1m and 1m, I have 2m's. I'm going to cross that off, cover that, multiply the bigs, and there's only an m right there. So now my answer is negative 3m squared minus 15m. Now, I want to point out, if you decide to do this method, which I'm going to call rainbow or distribute, you can't just write the answer, because if you remember, I have all the answers right here. So you have to show me work. So if you decide not to do the box method and you decide to do the distributive property, you've got to circle and point to where it goes and then give me the answer. Okay. Let's look at number 13. The dimension of this is a 1 by 1, 2, 3. 1 high, 3 across. The nice thing about the box method is, to me, it seems like organization. It doesn't mean it works all the time, but it does mean that it helps out a lot. Notice this goes on top of that box. This goes on top of this box. This goes on top of this box. So now I multiply the bigs, add the littles. Put an imaginary 1 here. Multiply the bigs, add the littles. Multiply the bigs, add the littles. And now I rewrite it, make sure it's in standard form, highest exponent to lowest exponent, and make sure you know that's a positive. That's my answer. Okay? So this is only going to be part of it, so this page will be worth 2 points. And then you're going to turn the page, and we're going to do even more monomials, but we're going to do more complex monomials. Okay? So let's look at number 23. The dimension of this is a 1 by 1, 2, 3. So I play the same game, it's just a little bit more complex. Negative 10, 12x squared plus 5xy minus 11y squared. Multiply the bigs. Then x squared. I like to cover it. Multiply the bigs. And then now I'm going to cover both of these. I'm just going to focus on here. Negative 10 times negative 11 is 110. I can use my calculator. Y squared. Since there weren't any letters here or variables, all I had to do was just bring them down. Now I'm going to write my answer. And the rule for this is, in order for it to be in standard form, the x's beat out the y's, so it goes x squared then x. And then comes the y. And this is one thing because they're all touching. Let's try number 27. Dimension of this, all of that is touching. It's a 1 by, that's a plus by the way, 1, 2, 3. Negative 10x cubed y. This one's a little bit more complex. This is why some of you might not want to do the box, but maybe you want to do the box for this problem. There's certain ones where it's more advantageous to do the box. Some of us just, let's do the box the whole time. That's great. So I'm going to focus here because there is so much happening. So multiply the bigs, negative 10 times 3. Add the littles. I have 3 x's and 2 x's. Now I have 5 x's. And I just have 1 y. Now I cover up this one. Remember, I put an imaginary 1 here. There's so much happening, I need to stay focused. Negative 10 times 1 is negative 10. I have 3 x's and 1 x. Now I have 4 x's. I have 1 y and 1 y. Now I have 2 y's. So now I finished the second one. Now let's focus on the third one. Negative 10 times negative 1 is positive 10. I have 3 x's and none here, so I've got 3 x's. I have 1 y here and 2 y here. I have 3 y's. Now remember, the x's beat out the y's, so 5, 4, 3. It's in order. Oops, make sure you copy it down right. Minus 10x to the 4th y squared plus 10x cubed y cubed. Now, as a side note, it might be a little bit annoying to have to go back and forth and back and forth. Maybe what might be helpful, I don't know, it's just something I just thought of, is maybe take a picture of the answers, so then you just look at your phone and you can check it real quick, okay? I want to try one more example, and then I'm going to let you be on your own. The dimension of this is a 1 by 2. So I'm going to put a negative 1y cubed, 10x minus 1y. Multiply. Cover. Negative 1 times 10 is negative 10. I see that there's a y here, but x comes first. There's only one x, and there's 5 y's. Then I cover this. Negative 1 times negative 1 is positive 1. I have 5 y's and 1 y, and that makes 6. Now I have to make sure, remember, x's beat out y's. So even though it looks like the 6 it beats out the 5, x's beat out y's. So negative 10x y to the 5th, plus, you can put the 1, but I don't want to, plus y to the 6th. So your job is to also finish this page, which is also worth 2 points.